if an important thing here is to use a reverse process with respect to the one that has been used here. And if I had to make a change to this file in Wikipedia, I would make this significant change. First, give the weight to the criteria, and then assess the candidates. This is because in a decision process, you have to set the rule for the decision before looking at the candidates. Otherwise, you know, after looking at the candidates, if you want to favor one of them, you may play with the weight of the criteria to favor him. Like in this case, I may have noticed that Dick was excellent in, I don't remember, education. Then I may play to force the weight of the education towards the top. So an important thing is, let's establish the rules before then looking at the candidates. This is an essential care that should be taken when taking a decision. Always remember, when you have to take a decision in whatever sector of your life, a very transparent way is, I don't want to know who is competing, just let's fix the rule first. This is extremely important. And I can tell you that my experience in the university, we changed it from a system for evaluating candidates that in the past was basically perceptual. And when you evaluate candidate by perception, of course, it's, you know, it may be really subjective. And it was a system that was highly criticized because it was deemed to be not transparent and not objective. And so we turned to now a system for the evaluation of the candidates that is very rigorous and making use of only a quantitative assessment. But one rule that we agreed in every application of this decision process is first the rule and then we look at the candidates. And first the rules and then the numbers, because otherwise, you know, once that you know the numbers, meaning the value of each decision, then you may play, and people may play and try to force. So for instance, with when we are using this decision process for design, and you have meeting with the population, first you identify the criteria, and then with the stakeholders you identify the weight to give to the criteria. And then, once that the weight has been established, then you disclose the information to the stakeholders. And the information may be what are the alternatives, what are the analytical functions that are used to evaluate the indicators and etc., to evaluate the scores and etc. This is extremely important. Now let's say also that there are some drawbacks of these rigorous decision processes with respect to a perceptual decision. The drawback is essentially that any fixed rule is an obstacle to the application of what we in Italian call the good sense, which means the application of a reasonable judgment. And because, you know, it's like laws, which we strictly need. What is the reason why we need laws? Because we have people that want to cheat. If we didn't have anybody that wants to cheat, then laws would be unnecessary and decision could be taken by just using expert judgment. Expert judgment is a good translation for what we call in Italian good sense. But, you know, given that we have people that try to cheat, then you need laws. But the laws are restrictive because it's clear that sometimes the laws need an exception, and sometimes you would like to make exceptions. But once that you have a law, you cannot. And also in the decision process, you know, the expert judgment, the subjective decision has some advantages because in some cases you need to make an exception to these strict rules. But when the decision is difficult, when there are people that, you know, even even with fair intention, want to try to drive the decision, then you need a rigorous and codified decision method. Which sometimes, it's a complication, and sometimes leads to a decision that may be that with an expert judgment results not really the most appropriate one. But we fully realize that in water resources management, what you need is transparency and rigorousness in the decision. Okay, so I went on for a while. Now, I think that now here I only miss an example of application developed with you. So let me postpone this to next time. And now I didn't take a break, and we have about, at this stage I would say that we have about 20 minutes. And what I propose to you is for just today to skip the break and close at 6:20. And now, given that you have the PC, I would like to use this time to make a discussion with you on the previous exercises. Will it be fine with you? Of course, if you need to make a very short break, we can do that. But if you can, I will just move forward for 20 minutes. Okay, do you have some battery in the PC for 20 minutes, or would you prefer? The camera has battery, so I think I can just do like this. Okay, so let me go back to our last exercise, which was IO. It's here. So basically, the exercise was the combination of I mode. And I just want to remind you, there were river flows and rainfall and evapotranspiration data. And we decided to use the sum of squares as objective function. And I suggested also to perform a comparison by using the sum of absolute squares, absolute errors. And there was another development here. I suggested to perform model calibration in a second stage by using a reduced amount of data and then using the data that were not used in calibration for performing a validation. Okay, and then let me just show you the code. This is the code that we used. I already explained to you the code a little bit. I didn't go into the details. And again, once again, I would like to tell you that it would be nice, a very good experience, if you tried at least to understand what the code does. Because in principle, you would be expected to write the code on your own. I understand that this takes time, and I don't want to say that this is necessary, but at least we should try to understand what the code does. And the code here is commented in Italian, but if I remember, I think I prepared also a version in commented in English. Anyway, this is not important for now. And I just would like to understand what you did. So basically, I think that we together got to a first calibration. Is it true, or I don't remember well? Did we perform together a calibration? In any case, I would like to please raise your hand. Who calibrated at least the first calibration of the model here? And who did that? I remember one person, you, just one person. Okay. This is not a problem, I just want to understand at which stage we are. So, okay. So it's better if I start from the beginning, from scratch, and we try to perform the calibration together. Okay? And who doesn't have the PC? You all have the PC, or no? You don't have
well, actually, we're not following the use of the software. Since the commencement of...
Sorry?
I'm saying, me in particular, I'm not following the use of the software.
Ah, okay, okay. Okay, that's fine. Okay, so let me try then to... I think in 15 minutes I can get to the calibration. So I think it's useful, if you didn't calibrate it, it's useful if we try. And the only thing is that, you know, I have to upload the data, but this is not a big problem. Just give me a couple of minutes to do that. And the text is here. So it's okay, let me download here. Hopefully I can get the connection, or otherwise I can. Yes. Okay, one is here. Okay, so I'm just uploading the data now. Can I just ask you, because I can't connect to the web, it was the length of the time series was 3,650. 10 years of daily data. Okay, it seems that I got to the see.
You have to skip 3 rules or something.
Okay, okay, that's fine. In any case, I think I can get here. No, it's, okay, it's this. Just 1 second.
No, you do this every single time. Not every single time. Yes. No, you have to change it back to first. We have to do P bar rain, because the rain, because this P bar equals the rain, P bar divides it into 5. This instead of rain, instead of P bar multiplied so rain equals
Allora, serve la punta del Raimond
this one plus we have rain. We did this rain then.
what I did so far is to upload the data, and I'm not sure whether you got at this stage already. Okay, so let me see. Let me show you how I did to upload the data. Okay, we can do this together. And I hope you already have the file of the TXT file that I provided to you. Everybody has that available in a path. Okay, that's fine. So let me start from scratch. And what you have to do, first of all, is to scan the file. So what I just find the name of an dummy variable like PR1, and then you make scan. Right, let me. Can you see it now? Yes. Scan, and then you need between commas the name of the file. And the name of the file is, in my case, the path is important. So if you have it on your desktop, there is the usual problem in Windows to find the path of the desktop. Let me type mine. Remember to complete the name of the path that you can use the tab. So in my case is ST, and then I complete, and then it's desktop, and this is my desktop, and then I can write the name of the file, which it is for you rain evapo. In my case it's just rain. And you need also to skip 3 lines. This is the instruction, and then you see that I read 17,420. Are you all here? Okay, good. Let me do the same for the river flows. So in this case is PR2, scan, and then again I have home, and skip equal to. Okay, in this case 2 lines you have to skip. Now the problem is that the first variable PR1 contains both rainfall data and potential evapotranspiration data. You have to split them. Now for splitting, I suggest to do this. You get again PR1, which is given by array made up by using PR1 himself with the dimension which is equal to 28760. In this case, what you did is to split the vector in 2 columns of a matrix. And have a look at the first column. PR1, square parenthesis, 1, first column, and this, let's look at only the first 10 elements of the first column. Just to make a check. You see that they are all 0. Fine. This is rainfall. If you look at the second column, you see they are all equal to the potential evapotranspiration. So we got to the result of splitting the 2 kind of data. Now I just need to assign the first column to a variable named P. I use P because the IMOD code is using this name to identify the rainfall. So P is equal to PR1, open the square parenthesis, 1, comma. That's it. And then evapo equal PR1, 2, comma. And then let's name the observed river flow as QOS equal to PR2. Now with the variables we are done. If you have any questions, should I repeat?
No.
I don't want to discourage you. It's just if you have some problems, can we discuss that? No. No way. Okay. Now let me move to the software. The software is here, as I downloaded from the website, I needed to make the following changes, which we already discussed. Timestamp, change it to 3600, because these are hourly data. Number of time steps, change it to 8760. Let me look at the code in my website, sorry, because I have a doubt. Maybe that in my website already code, it's here. Yeah, I think it's take the code on my website and then let me see if I can increase the size. Yes. And then please be careful. Change the time step is already okay. Change number of time step to 8760. And it's already commented in English here. So you are already served with this. You have to just change this one. Okay? And then that's it. Yes, that's it. What you have to do, directly from the website, you may select all. Okay? And then, if you didn't have to make any change, you could just copy. So right-click, copy, and upload in R. R is here. Just click with right, paste, and that's it. The only problem is that we have to change the number of time steps. So let me, in order to change it, let me open a text editor, like this one. I paste here. After having pasted, I change the number of time steps, and then I can again select all, copy, and then go to R. That's it. Now I can make a trial, like the function is named imod, and it needs the parameters. The parameters let me just make a trial, like 200, and then a sequence of 0.5s. And then you get the computation of the sum of the squared errors and the graph. Here, of course, it's not good, the simulation. Okay? And I'm just wondering, the red is observed or simulated? Let me check what is the red. And QoS, okay, red is simulated. Yeah, red is simulated. I don't understand why the observer is so reduced. There is something that I don't understand, but okay. Let me make another trial then. Because you know, here you can play with the parameter as you like. So let's try here to put 1000 and see if something changes. Yeah, indeed it is decreased. Still, I don't understand why the observer is so low, because if I do max QoS, it's 7. Yeah. Don't understand it. Should be higher. I think I made a mistake in uploading the data. Now, in any case, apart from...
I think the last one, you know, the reservoir, is it slower or faster? The last one?
Sorry?
The last one, the last parameter. I think you said last time you said the maximum value for that was 1 over 1000.
Yes, the only problem is that what is 1 over?
So it should
Yeah. The only problem is that what's wrong here is the observed. Because, you know, it's the observed, it's the black one which is observed, that is too reduced. So, and also if I type now maximum of Q observed is 7, which is not good. So I think I made a mistake in uploading the data. So let me just check, but I think this was the problem. But in any case, we can move forward next time with this. I just would like to check if flow txt, yeah, there is something. I didn't upload well the second one, so if I repeat this, like, you have to scan. Okay, now let me run it again. Let's see what happens. Just a moment. Now should be okay. Yes, now it's okay. Okay, so we are at this stage here, and you may remember that we decided to remove the first part of the hydrograph because I said it's, of course, the simulation there is highly unreliable, and we didn't calibrate so far. So next time, if you were able to get to this stage where you uploaded the software and the data, we can move forward with calibration. Okay? So my suggestion is for Thursday, we dedicate all the 3 hours to exercises. We start with this, I show you how to calibrate, and then we move to the next exercise, which is decision making, application of pairwise comparison. Good. Now I have to rush. So please accept my apologies. I cannot stay if you have any question. But if before Thursday you have any question on uploading the data, on Wednesday I am in my office in the morning. If you want to come and visit me, just send an email to confirm, and we can fix an appointment like at 9:30. And you come with the PC and we solve the problems, okay? Or if you, on Wednesday I am in the office, so if you want to meet me in the afternoon, that's fine. Send me an email and I can fulfill to you the appointment.